So in terms of training a custom YOLO v4 Tiny model, I needed to install Darknet, which is the framework that YOLO v4 Tiny uses. I opted to go through this whole process on Linux because I tried it on Windows and I found it a bit too restrictive in terms of install permissions. Linux was just easier. It wasn't so restrictive. So the distribution that I used on Linux was Pop! OS. It's based on Debian, which is just like Ubuntu, but it just means the commands I'm going through here are going to be Linux commands. So the first command that I ran was git clone to download the whole Darknet repository. And after downloading Darknet, the first thing I did was to make some changes to the make file used by Darknet. You can see that here. We have a couple of variables up here that I was going to be changing. So the changes that I made were GPU1, that accelerates the training using the GPU. CUDNN1 just says build with CUDNN, which is required if you're going to use a GPU. CUDNN half1, same again, just speed up detection using the GPU. And OpenCV1 says build with OpenCV to allow detection from video streams and videos, stuff like that. I also changed this arch value to, you can see these values 61, SM61, Compute 61. And that's based on the NVIDIA compatibility chart, which you can see here. So NVIDIA are saying if you're using this graphics card, you need to use version 6.1, and in the make file, just write that as 61. With these changes made, that was my changes to the make file done. So I then went into the Darknet directory and I ran the make command in the Darknet file, or make file, to build the Darknet executable based on those changes. That was the easy part in a sense. So within the step of installing Darknet is the need to install CUDA and CUDNN. You don't technically need to do this, but I did because I wanted to use YOLO with my graphics card, because the computer has a graphics card and it's much faster to train rather than just using the CPU. So to do this, I followed a lot of guides, and a lot of them were useless. The one that actually worked almost perfectly for me was this GitHub gist. The steps that this goes through are, number one, verify the system has a CUDA capable GPU installed. Not all of them are CUDA capable, but mine is, the GTX 1060. It's an older card, but it's recent enough to be CUDA capable. We have, well, obviously we have to first purge any previous installations of CUDA and CUDNN that we have. Then next up, we have a lot of different packages that we have to install for this to work. The first of which that I'm going to talk about later is G++ or GCC. That's a C++ compiler that Linux uses. As I say, I'm going to come back to that later on because I had to make some changes relating to that. Next up, we add the PPA driver, which is the driver Linux uses for dealing with proprietary graphics drivers, such as the NVIDIA drivers, which is what we're using in this case because we have an NVIDIA graphics card. Then we install the NVIDIA graphics cards or drivers themselves. We download CUDA and CUDNN. We install CUDA. And then we have to set up these environment variables so we have system-wide access to our CUDA and CUDNN installations. Following that, we use this wget command, which is like curl to download the tar file for CUDNN, and we use the tar command to unzip it. A tar file on Linux is just like a zip file. Following that, we use the cp command a couple of times to copy some files from the CUDNN directory into our CUDA installation directory. And finally, we just verify that our installation worked using this nvd smi nvccv command, which just tells us what version of CUDA that our NVIDIA driver installation is using. We then install PyTorch, which is just a machine learning framework that we can use for training our models. Now, as I said, this didn't work perfectly for me, so I needed to make some changes along the way as I ran through this gist. When I ran the wget line to download CUDNN, that didn't work because wget tried to download the HTML page that the file was hosted on rather than the file itself. So instead I just opened that page and manually downloaded the tar file. After that, I had to give myself permission to download that file or to use the file, so we used the sudo chmod 777 command on the file to give read, write and edit permission on that file to myself. I then used the tar command again to unzip it and restarted the computer. And then in my case, there were a couple of files missing from the CUDA installation because it seemed to have installed into two separate directories. So to fix this, I copied the following files, these ones, from the CUDA/include directory on Linux to the user/local/CUDA 11.3/include directory. It took some trial and error to figure out which files were missing. Just kept trying until I got them all. I then added two more environment variables to get system-wide access to both the CUDA bin and lib directories, because I didn't have access until I added those. I then again used the nvcc-v command to find out what version of CUDA I had installed, and it told me CUDA 11.3. However, when I ran the NVIDIA SMI command again to see what version I was actually using, the OS said that it was using CUDA 12.1. And if we were to look into the makefile used by Darknet, which I showed you there earlier on, we'd see somewhere in here that it wants to use CUDA 11.3. And I mentioned earlier that we'd refer back to the GCC C++ compiler used by Darknet, and this is where the problems came from for me. GCC threw errors telling me that the installed version of GCC was incompatible with the version of CUDA which I had installed because it was too new. Again, it was telling me that CUDA 12.1 was installed, even though I had just installed version 11.3. To fix this, I added a new environment variable to my bash rc file to tell it the max GCC version to use is 10, based on a compatibility chart that I got here, where it tells you that CUDA version 11.3 needs GCC version 10. So it made sense to tell it the max version to use is version 10. Then when I added this to the Darknet makefile to ensure it was definitely using the right version of G++, I added this variable to the makefile. So it definitely matched up with the version of CUDA that I had installed. After that, that was Darknet set up and ready to go. So it was just a matter of downloading my data from RoboFlow, which was already split up into train, test, and validate sets, and is already in the format expected by Darknet because you can just export it from RoboFlow in whatever version you want. I just had to make some changes then to Darknet's default configuration files to change the default number of classes from 3 to 44, which was the number of classes I had. And then after that point, you just start training. That took around 9 hours, which resulted in a YOLO v4 tiny weight file that I could pass into OpenCV and use for object detection.